What's going on, everyone? The COVID quarantine has us all pretty bored, so I decided to put together this little temperature probe thing. Had some parts laying around. I also got a new resin 3D printer, so I wanted to put it to test. This is a little overexposed, but this is like my third print, so I'm still trying to figure things out. This is an entirely self-contained unit running on Atmega328 and USB power, so you can pretty much just plug it into any USB port. My plan is to plug it into a power bank for portability. Get it plugged in. There's the splash screen. And there you have it, a temperature probe. I'm going to go ahead and put it into some ice water I had here on the desk. And then we'll just watch it go down for a little bit before we get into how I developed it. Everything was developed first on an Arduino Uno. This is the DS18B20 temperature sensor. I have it in the encapsulated version, so it's waterproof, and I just have it hooked up in normal power mode to the 5-volt connection. The neat things about these sensors is that they run on the one-wire interface, so you can hook up a bunch of them to one digital pin on your microcontroller and get readings from all of them. The OLED screen here is just hooked up to our 5-volt supply line as well. This is the data line for the temperature sensor. It uses a 4.7 kOhm pull-up resistor tied to the positive rail. These are the serial data and serial clock pins for interfacing with the OLED on the I2C interface. Just to show that it works, I'll plug the Arduino into USB power, and it lights right up. So there is a maximum temperature for these probes. It's stated in the datasheet as 125 degrees Celsius, so I also wanted to add a warning flag if the temperature probe got to 100 degrees Celsius, so we know not to keep going, or at least just to be careful. And this is just an example. I lowered the threshold in the code just to show you what that flag would look like. Speaking of code, I'll give you a quick glance at that. Just a warning, I'm not a professional coder and I just do what I can. I'm sure there's more optimal ways to do what I've done, but here are the dependencies. Using the Adafruit graphics library as well as Dallas temperature for running the temperature probe. Here's where the OLED screen is set up, and just below that is my custom splash screen, which I made on the image to CPP tool I found online. This is where the temperature probe is set up. Just below that is my warning flag variable to set if we're approaching that temperature like I was talking about. At the end of my setup is where I have the splash screen show right before we get into the main loop. So the first thing the main program does is check the temperature and then see if it's over 100 degrees Celsius. If so, it turns the warning flag on. If not, it makes sure the warning flag is off. Next, the program sets the top header of the screen, which is just Mike's temp probe, because no matter what we're doing, it's going to show that. And if the warning flag's on, it sets up all the temperatures and then puts up the warning flag at the bottom so you know that you're going to approach that temperature limit, as you see right here. If the flag's not on, then it just shows the temperatures as normal. Now, as always, I wasn't paying attention when I bought the Atmega328 chips, and I got ones that were slightly different but still pretty close, so I had to go into the configuration and just edit it a little bit to trick it into thinking the chips were different from what they actually were. Since it's a fresh chip, I had to burn a bootloader onto it. Once the bootloader is on, it's as simple as just uploading sketches straight to it through a programmer. I have a programming shield I bought a long time ago. There's a lot of different ways you can do this. Now that the program's been burned onto there, I can simply plug this little USB component in, and there we have it. Now for the fun part. Let's get it off of the breadboard. As with every step, we have to make sure it still works. Don't mind all my hot glue insulation, I just like to make sure we don't have any accidental shorts. Now it needs a case, so I just whipped up something really quick in Fusion. Got it set up for my new resin printer. Then it took about, I would say, 7 hours or so to print. Then I just snapped it all together into what you see now. I hope everybody is staying safe out there. If you like what you saw, please like the video. Drop a comment about any thoughts you might have, or if you made any similar projects, or if you have any questions about how you can make this yourself. I've got a lot of projects in the queue, and hopefully there'll be a lot more videos soon. Thanks for watching.